Part 2, angles of triangles. Some of this stuff you guys already know. So how many degrees are in a triangle? 180 degrees. So triangle angle sum theorem says that. It says the sum, what's that a fancy word for? Add, right? The sum of the measures of the angles of a triangle is 180. You've known that for forever, okay? Auxiliary line, we had that in our last chapter. Remember when we drew that parallel line and we did like alternate interior to find the angle, right? So an auxiliary line is an extra line or segment drawn in a figure to help analyze geometric relationships. Sometimes you use it, sometimes you don't, but that's the vocab, okay? Exterior angle theorem. This is probably new for you. The measure of an exterior angle of a triangle, so exterior means outside, right, is equal to the sum, fancy for plus, of the measures of the two remote interior angles. So let me show you what that means with the picture, okay? Angle 1 would obviously be the exterior angle. It's on the outside of that triangle. Does everybody understand that? Okay. All three of these are interior. Does everybody understand that? Right? But these two are called the remote interior because they're not right next to the angle 1, the exterior one. Those are called the remote interiors. So if I had extended the line this way instead and talked about this exterior angle, my remote interior angles would have been those two. Do you guys see what I'm saying? That's a remote interior angle, the ones that are not that are inside but not attached to the exterior one. Okay? And if you don't get that, I'm going to show you another way to do it in just a second. Are you ready for your test? Okay. Just leave your phone in here if you have one. That's right. Okay, so like it said up here, the exterior angle, angle 1, is equal to the sum of the two remote interior angles, so 2 plus 3. That's what this says right here. If you are not a memorizer, this is one that you can kind of work around. Sometimes it's not an option. Sometimes with a theorem, the only way to do it is this way. But with this one, let's pretend this was like 100 degrees right here, okay? If this is 100 degrees, what's this? 80. So couldn't you just say these three add up to 180 instead? Do you see what I'm saying? So if you're a theorem person and you can memorize them, this one's fine to memorize. It's a step quicker, but if not, it's okay to just say these are a linear pair and just add these three up equal to 180. That's okay too. I don't force you to use it unless you have to, which I don't think you ever would have to. But it's quicker. So there you go. Okay? All right, find the measure of each numbered angle. So just like before, I'm not going to do them for you all the time. Sometimes I want you to at least try to find one or two without me. So we're looking for angles 1, 2, and 3. I want you to try to find at least 2 of them without me helping you at all. Most people can find one pretty quickly, pretty easily. The second one they have to think about a bit, and then I'll definitely help you with the third one. So find any 2 angles. I'm not saying 1 and 2. I'm saying any of the 2. Find those and see what you get. If you found some, lean to a neighbor and see if they got the same as you. Excuse me. Once you find 1 or 2 of them, lean to a neighbor. Okay. Anybody find angle 1? 42. Okay. So angle 1 is 42. I'll show you how you can get that if you didn't notice that one. So if you look at triangle ABF, does everybody see this triangle here? That's 3 angles, so they must add up to 180, right? So if you do 180 minus the 90 minus the 48, that's where the 42 came from. Okay, because these are notes, I kind of like to write this down. That way, when I come back to it later, I'll remember how I got that. On your homework, obviously, you don't have to write that down. I understand that you can punch that into your calculator and just get 42 on your own. That's fine. Does everybody understand that? Okay. Angle 2, anybody think you got that one? Hmm? Good, it should be 39 degrees. There's a couple ways you can do that. Does everybody understand that line segment FC and line segment DE are parallel lines? Does everybody see these little arrows here, right? So these are 2 parallel lines cut by a transversal. So angle 2 and this 39, what's their name? Alternate interior. When we have 2 parallel lines cut by a transversal, what do we know about alternate interior angles? They are the same, congruent, very good. So if this was 39, then this had to be 39. So for my notes, I let myself know it was because of alternate interior angles. Again, on your homework, if they didn't ask you to justify, you could have just said 39 and that's fine. Anybody confused? All right, somebody new. What'd you get for angle 3? Ryan? Mm-hmm. How'd you get that? Okay. Okay. You mean like this one here? Okay. Okay. That is one way to do it. We don't know what's the word? We don't know properties of parallelograms yet. So you are right. Everything you said was right. But some people may not know that yet. So I'm going to solve it a different way. You're not wrong though. I want you to understand that. Does anybody do it a little bit differently than that? Uh-huh. Right. Yeah. So the thing we for sure all know is that this triangle here adds up to 180 degrees, right? So we could have done the 180 minus 90 minus 39, okay? And that's how we could have gotten that angle. Does everybody understand that? So what Ryan said was not wrong, but we don't actually, this year we'll get into properties of parallelograms and squares and rectangles and stuff, but for today I think the safest way to do it was the triangle adding up to 180. But the other way was right too. Did I lose anybody there at all? Okay. On this one, they want to know the measure of angle ABC. Angle ABC, I want everybody to mark which angle that is. I want to make sure you guys can do that right now. Find angle ABC. Okay. ABC is this one right here. Everybody get the right one? Okay. So obviously they want us to use our new exterior angle theorem. That's the goal, all right? So does everybody understand the 148 is the exterior angle, and then A and B are the remote interior angles. Does everybody get that? So the theorem says that 148 is equal to those other two added up. But what I want to show you is you didn't have to do it that way. I think it's great to know the theorem and to do that, but if you're not a theorem person and it's really hard for you to remember things like that, couldn't you have subtracted from 180 here because of this linear pair and just said these three add up to 180 instead? It's one extra step, okay? So I'm going to do the theorem because that's what I'm supposed to do to show you, but if you ever wanted to do it the other way, that's okay too. Is that all right? Okay, take your time and solve for x for me, please. So while you guys are doing it, I'm going to do it just for the sake of the video so people can see in case they get it wrong. So you always want to combine like terms before you move things around. So 2x and 1x is obviously 3x. Negative 15 minus 5 more, negative 20, right? So I'm going to add 20 to both sides. And then what? Divide by the 3 and we get 56 for x. Is that what they wanted? No, they wanted the measure of angle ABC, right? So angle ABC, they said was x minus 5. So how am I going to find it? Yeah, so substitute the 56 in, right? 56 minus 5 is 51 degrees. Measure of angle ABC is 51 degrees. Anybody confused at all? Pretty easy, right, if you know the theorems? Anybody still need that page? Okay. On this one, same thing. I'm going to ask you to find at least 2 of these without me. I don't care which 2. You look at the picture, solve it any way you want to. Find at least 2 of those angles without me telling you what to do in the beginning. Okay? Feel free to lean to a neighbor when you think you found one. See if they got the same as you if they did that. Okay. Did anybody think they found angle 2? What's that one? Should be 39 degrees. Here's how I did it. If you look at this triangle here, okay, where the angle 2 is, if this is 90, linear pair, that has to be 90, right? So I did 180 minus the 90 minus the 51, and I got 39. That's how I got angle 2. Everybody okay? All right. Anybody think they got angle 4? Huh? Very good. How did you get that? Oh, I see. You looked at this big triangle here. Very good. That is one way you can do it. So if you guys look at this triangle here, does everybody see that one? Yeah? So we have 35 degrees here. We have the missing angle 4 here. And we have 90 here. So he said 180 minus the 90 minus the 35, and that's how he got 55. That's one way to do it. But some people didn't see that big triangle in that way. I know some people in the other class looked at this triangle here, and they found angle 5 even though we weren't asked to do that. Does that make sense to you? So they took 180 minus the 90 minus the 35, and they found angle 5. And then they subtracted that from 90 to find angle 6. And then they subtracted from 180 to find angle 4. Those are, you do whatever you want. You do whatever kind of jumps out at you, okay? So anybody that found angle 6, what'd you find? 35, okay? So again, multiple options. For angle 6, again, if this is 90, this is 90, right? Linear pair. So once we knew angle 4 is 55, I just did 180 minus the 90 minus the 55 here. Is that okay? Or you could have done what I had just said. You could have found angle 5 and then subtracted it from 90 to find angle 6. Either way. Did I lose anybody anywhere? Is anybody confused? Anybody solve it a different way? Want to make sure it wasn't just like a happy accident? Okay.